Now I'm implementing the create block functionality inside the admin panel. I start in router.txt by defining a new LiveView route. The new atom action is important here. It tells the LiveView which state it should operate in. Instead of creating separate modules for each operation, I can reuse the same LiveView and switch behavior based on live_action. In this case, new atom indicates that we are initializing a fresh block creation flow. Next, I create form.txt inside the block_live. I define the mount function. I'm moving the setup logic into apply action to keep mount minimal and action driven. This keeps mount clean and makes the code easier to extend when we add more actions like edit. I rely on socket.assigns.live_action, which Phoenix automatically assigns based on the route. This allows me to dynamically configure the LiveView depending on whether I'm creating or editing a block. Now I implement apply action for the new case. I am creating a new block struct as the base state for the form which represents a new record. Then I assign 3 key things to the socket: page title for UI context, blog, the base data structure we will work with, form generated using to_form, which wraps an Ecto chain set into a structure optimized for form handling in LiveView. The chain set comes from blogs.change_blog, which I will define next. Now I move to the blocks context and implement change_blog function. This function is responsible for producing a chain set. It acts as a boundary between the LiveView and the schema layer, ensuring that all validations and casting logic are centralized inside the block schema. By calling block.chainset, I prepare the data structure that will power both validation and persistence. Next, I create form.html.hix. Instead of embedding the template inside the LiveView module, I separate it into its own file for better maintainability. .hix stands for HTML Embedded Elixir. It's a templating format used by Phoenix that allows embedding Elixir expressions directly into HTML while remaining efficient and compile time validated. Now, focusing on the form itself, I bind the form to add form, which comes from the chain set. phx change validate enables real-time validation as the user types. phx submit save handles form submission. Each input is connected to field in the chain set: title, content, image_path. For now, I'm skipping image upload functionality. I simplify the validation logic by removing image_path requirements and relying on a default value. This keeps the scope focused on core form behavior. Now I go back to form.txt and implement validation handling. Here I take incoming form data and generate a new chain set. Setting action validate is critical. It tells Phoenix to display validation errors without attempting to persist data when I update the form assign, which triggers a render with validation feedback. Next, I handle form submission. Instead of embedding logic directly, I delegate to save_blog. This keeps the event handler minimal and makes it easy to support multiple actions like new and edit. Now I implement save_blog function. Here I attempt to persist the blog using the context. On success, I set a flash message for user feedback. I redirect back to /admin/blogs using push navigate. On failure, I reassign the chain set to the form. This ensures validation errors are displayed to the user. Now I go back to the blocks context and implement persistence. This function constructs a new block struct, applies validations via the chain set, and inserts it into the database using repo.insert. This keeps all database interaction encapsulated with the context layer. Finally, I update index.txt to include navigation to the form page. Now I test the flow. I create a new blog. The record is persisted successfully, and I see the flash message coming from the operation. Everything works as expected. Next step, implementing edit functionality on top of this foundation.